Hello everybody, welcome into another lesson. So today we are going to talk about inverse variation. And it's really not any easier or any harder than doing direct variation. I mean, it's one thing that's the same as you have the k, the constant of variation, like you would in direct variation. But inverse variation is a little bit different in the fact that your problem is going to read something like y varies inversely as x. In yesterday's lesson, we talked about direct variation where it would have said y varies directly as x. Today, we're talking about y varies inversely as x. Whenever you have that, y varies is going to be y equals. The inversely means it's your constant of variation divided by x. That would be inverse variation. Y equals your constant of variation k divided by x, or k over x. So that's what inverse variation is all about. And this should be a relatively short lesson. So let's get into our first example here. Let's see. Y varies inversely as x. Y equals 54 and x equals 4. Find y when x equals 8. Alright, so we have y varies inversely as x, and they give you that y equals 54 and x equals 8. Then they want you to find y when x equals 8. Well, like the direct variation problems, first thing you're going to do is ignore the last sentence. Find y when x equals 8. Forget it exists for a minute. What you want to do is set up your initial equation with y varies inversely as x, alright? So y varies inversely as x means y equals k over x. Well, in this case, of course, like you wanted to with direct variation, you want to find your constant of variation first. That's the first thing you should want to find is your constant of variation. In order to get the k by itself, because this k divided by x, you have to multiply by x. So if you multiply the right side by x, you get k. That's going to be equal to, but what you do to the right side, you got to do to the left, that would equal xy. So the equation for the constant of variation is k equals x times y, or xy. Now, in order to find that constant, all we have to do is plug in the initial values that were given to us. So k equals, the x value is 4 times your y value of 54. So to find the constant of variation, you're just simply going to take 54 times 4. Which I want to say is 216, but I was right, 216. Okay. So the constant of variation is going to be 216. So now we have identified the constant of variation, k, to be 216. So next step, like in direct variation, the next step is to find the new equation that involves the constant of variation. That's going to be left as y equals k, which is that constant of variation of 216 all over x. So there is your new equation that involves the constant of variation, y equals 216 over x. Now, we've identified the constant of variation, and we've identified the new equation with that constant. Last thing we have to do is find y when x equals 8. So all we have to do to find y, we'll set that equal to 216 over the x value of 8. And that'll give us an answer. All I have to do is 216 divided by 8. That gives me 27. So when x equals 8, I get a y value of 27. So that would be the answer. Y would equal 27. And I do have more. I got plenty more where that came from. Alright. Let's see. We're not pretty much going to be the same but different values. Let's see. Y equals 9. X equals 32. Find x when y equals 12. Okay, so a little bit different equation here. A little bit different. So y varies inversely as x. Y equals 9 and x equals 32. Find x when y equals 12. Well, again, start out with forgetting the last sentence exists. Start with your y varies inversely as x. So that's going to be y is equal to k over x. That's the equation for y varies inversely as x. Now, first thing we want to do, once again, find that constant of variation, so you got to multiply both sides by x. You multiply the right side by x, you just get k. Multiply the left side by x, you'll get xy. So k equals xy. Now in order to find that constant of variation, all you do is plug in the two values of x times y. X was 32, and then y was 9. So all I have to do now is take 32 times 9 and I'll have my constant of variation. So let's go ahead and do that here. That gives me 288. So my constant of variation turns out to be 288. That's the value for k. So now that we found the constant of variation, let's find the new equation. Well, let's see, that's going to be y equals 288 divided by x. So the new equation that comes with the constant of variation is y equals 288 over x. So that's step 2. Now that we found the constant of variation in the new equation, we can focus on the last sentence. Find x when y equals 12. Well, what we have to do, once again, plug in your values, but this time they give you y. Y equals 12. You'll have 288 over x. This actually isn't going to be too bad, because we want to get that x out of the right hand side and move it to the left. In order to do that, we have to multiply the right side by x, which would give you 288 if you did that. But that means you got to multiply the left side by x, so you would get 12x. So 12x equals 288. Well, we want to solve for x, which means you're going to have to divide both sides by 12. So if I do that, on the right side I get x, and then the left side I divide that by 12, I get 24. So that's my answer. When y equals 12, x equals 24. That would be my answer. And that's all there is to that one. Alright, what's the next problem? Let's see, y is equal to 10.5 and x is equal to 11.7. Alright, find find x when y equals 19.5. Alright, so we got this problem here. Y varies inversely as x. They give you y equals 10.5 and x equals 11.7. Find x when y equals 19.5. Well, again, start with forgetting the last sentence exists. Start with y varies inversely as x. Y varies inversely as x. So that means y equals k over x. So once again, we want to get that, we want to solve for the constant of variation. So we got to get k by itself, so we got to multiply both sides by x. If you multiply the right side by x, you do get k by itself, which means you got to multiply the left side by x, you'll get xy. So the constant of variation is equal to x times y. Now, in order to find said constant, you just got to plug in those values of x and y. Well, x was 11.7. Take that times your y value of 10.5. And then, now you just multiply the two, you'll get your constant of variation. So we have 11.7 times 10.5, which comes to 122.85. So your constant of variation in this case is going to be 122.85. So you found your constant of variation. Next thing you need to do is find the new equation, which will take the form of y equals 122.85 over x. So your new equation is y equals 122.85 over x. So now that you found your constant of variation and your new equation, you got to focus on the last part now, which is find x when y equals 19.5. So we're finding x. They give you y as 19.5, so plug that in. 19.5 equals 122.85 divided by x, because x is the value we don't know that we're trying to find out. Well, we ultimately want to solve for x. In order to do that, we got to get it out of the denominator, out of the right-hand side. So we have to multiply the right-hand side by x. If we do that, we get 122.85. But what you do to the right, you got to do to the left. You'll multiply 19.5 by x, you'll get 19.5x. So we have 122.85 is equal to 19.5x. And ultimately we want to solve for x, so you got to divide both sides by 19.5. Divide the right side by 19.5, you just get x. That'll be equal to 122.85 divided by 19.5. Which I get 6.3. So when y equals 19.5, x is going to equal 6.3. And that would be the answer. X ends up equaling 6.3. Alright, 3 more problems, then we're done. Let's see, y equals 1/4, x equals 8, find y when x equals 10. Alright, so we have the following problem. Y varies inversely as x, where they give you the value y equals 1/4 and x equals 8. Then they want you to find y when x equals 10. So, again, forget the last sentence for a minute. Focus first on y varies inversely as x, so go ahead and set up that equation. Y varies inversely as x means y equals k over x. So we've set up the equation. Now first thing we want to do is find our constant of variation. So what we have to do now, we want to get that k by itself, so we got to multiply both sides by x. You multiply the right side by x, you'll just get k. Then you have to multiply the left side by x also. You'll end up getting k equals xy. That would be the equation to obtain your constant of variation. Now, in order to obtain said constant, you just got to stick in the values of x and y and multiply them. So k would equal, your x is 8, times your y value of 1/4. Which 8 times 1/4 is 2. So your constant of variation, which we found, that's the first step, is 2. So therefore, k equals 2. Second step, set up your new equation with the constant of variation. So that would be nothing more than y equals 2 over x. So therefore, the new equation is y equals 2 over x. Alright. Last step now that we have found our constant of variation in the new equation for the inverse variation with that constant, the last step is to deal with the last sentence. Find y when x equals 10. So they want, this time y is the unknown variable. So we're going to set y equal to that 2 over that x value of 10. Well, all we have now is y equals 2/10, which we know reduces to 1/5. So when x is 10, y equals 1/5. That would be the answer. When x is 10, y is 1/5. I got 2 more problems here. Alright, they changed the variables in the last 2. So let's see, we have m varies inversely as d. They give you where m equals 12 and D equals 30. Find D when M equals 9. Okay. So very similar problem, they just changed the variables. So we have M varies inversely as D. They give you M equals 12 and D equals 30. Then they want you to find D when M equals 9. So forget about the last sentence for a minute. Start with M varies inversely as D. That's going to look like M equals K over D. That's how you would set up M varies inversely as D. M equals K over D. Well, like in the past 4 problems, you want to find your constant of variation. So you got to multiply both sides by D to get the K by itself. You do that to the right side, you will get K by itself. Do it to the left side also, you'll get MD. So K equals MD. Now we found the equation for the constant of variation. To solve for the constant of variation, you just plug those two values of M and D in and multiply them. So K would equal 12 times 30. Now you just multiply 12 times 30, that would give you 360. So the constant of variation in this case is going to be 360. So that's step 1. Step 2 is you need to find the new equation with that constant of variation. That's going to look like M equals 360 all over D. So that is your new equation, is M equals 360 over D. Now, we have found our constant of variation in the new equation of inverse variation. Last step is focus on the last sentence. Find D when M equals 9. In this case, they give you that M equals 9. So put in 9 for M. That'll equal the 360 divided by D, because ultimately we want to solve for D. That's our unknown. So 9 equals 360 divided by D. Well, we need to solve for D. We can't do that if it's in the denominator. We need to get that out of the denominator and out of the right-hand side. In order to do that, you got to multiply the right side by D. If you do that, you just get 360 on the right-hand side. That'll be equal to, now you got to do it to the left also, that'd be equal to 9D. Well, ultimately we want to solve for D. We have 9D. We want to solve for just D. Now you just divide both sides by 9, you get your answer. D would equal 360 divided by 9, that'd be 40. So when M is 9, D is 40. That's the answer you would get. When M is 9, D is 40. And I have one more problem. Just one more and we are done for the day. Okay, what do we got here? See, this time M equals 60 and D equals 9. So we have M equals 60, D equals 9. Find M when d equals 5. Alright, so we have the problem here of m varies inversely as d. They give you m equals 60 and d equals 9. Find m when d equals 5. So start with, forget the last sentence exists for a minute. Start with m varies inversely as d. So you're going to set up your equation, m equals k over d. So there's your initial equation for m varies inversely as d. Now next thing you need to do, of course, is isolate that k by itself to solve for the constant of variation. That's our first goal. Well, you got to multiply both sides by d. You multiply the right side by d, you just get k by itself, which means you got to multiply the left side by d, you would get md on that side. So you get k equals md. To solve for that's the equation to find the constant of variation. Now, in order to find said constant, we just need to plug in the values of m and d. So k equals the value of m, which was 60, times the value of d, which was 9. Now to find the constant of variation, just multiply 60 times 9. You're going to get 540. So therefore, your constant of variation is going to be 540. So that's step one. We've solved for the constant of variation. Now we need to find our new equation with said constant. That's going to look like m equals 540 over d. So the new equation is m equals 540 over d. So now that we have identified the constant of variation and found the new equation of inverse variation, last thing to do is to figure out the last sentence. Find m when d equals 5. Well, we don't know what m is. That's what we're trying to find out. So you'll set m equal to that 540 divided by the assigned value of d that they gave you, which was 5. So all you got to do to solve for m is figure out 540 divided by 5. That'll be easy. Just some simple division. I want to say 108, but let's be sure. I was right, 108. So therefore, when d equals 5, you get a value of m that is 108. So, yeah, that's really it for inverse variation. So the next lesson, we're going to talk about direct and inverse variation with quadratic variables. Because especially if you're dealing in any of the science fields or engineering fields or even financial fields, it's often not going to be a nice, pretty linear equation like we've been having. You're going to have some quadratics and even other powers. Now in this course, we only cover quadratics, thankfully. If this were Algebra 2, we'd be covering other types of equations, but this is only Algebra 1, so we're sticking with linear and quadratic. So next lesson will be about quadratic, direct, and inverse variation. So I hope everybody has a good night. Take care.